All right, so we're going to take a look now at some of the properties or the characteristics of alcohols. And in order to take a look at some of these properties, the first thing that we're going to have to do is to classify what type of alcohol that we're going to be looking at. And this is going to be extremely important, especially when looking at the chemical characteristics or the chemical properties. Okay, because the type of alcohol that you're going to be dealing with actually determines the types of reactions that it is going to undergo. So we can classify alcohols as belonging to one of three categories. They can be primary, which we abbreviate as 1 with a little degree sign, secondary, 2 with the degree sign, or tertiary, 3 with the degree sign. And the way that we are going to do this is to first of all locate the hydroxyl group. Right, remember the hydroxyl is the OH. Right, so we first of all find that, and then we locate the carbon directly connected to that OH. And then we ask ourselves, how many other carbons is that carbon connected to? Okay, and then we're basing our categorization or our classifications of the alcohol in that order. So we're going to find the OH. So if we look at the one over here on the left, there's our OH, or hydroxyl, and it's attached directly to this carbon here. So that's the carbon that we're going to focus on. How many other carbons is that directly attached to? Well, there's just one other carbon that's directly attached to. Carbon, let me insert this here, carbon directly connected to. All right, so if it's 1, then we say that that alcohol is primary. If that carbon is connected directly to 2 other carbons, then we say that it's a secondary alcohol. And then if that carbon is directly connected to 3 other carbons, then we say that it is a tertiary alcohol. All right, so if we take a look at the one in the middle, there's our OH. We find the carbon that it's directly connected to, which is that one. So that's the one that we focus on. This carbon then is directly attached to 2 other carbons. So this is going to be a secondary alcohol. The first one that we saw here was a primary alcohol. And then the third one here, there's our OH, find the hydroxyl group. This is the carbon directly attached to it. How many other carbons is this carbon directly connected to? Well, 1, 2, 3. So that would be a tertiary alcohol, right? So we have to identify what type of alcohol we're dealing with in order to determine what type of reactions it is going to undergo. So let's take a look at a couple examples. We'll take a look at maybe just a couple of these. So this is our first one here. Let's look at A. So find the OH first and identify the carbon that is directly connected to, which is that one. And how many other carbons is that carbon directly connected to? Well, we have one carbon here and we have another carbon on the other side. So that carbon, this one right here, is directly connected to 2 other carbons. So we would say then that it is a secondary alcohol. Right, if we take a look at C down here, there's our OH. This is the carbon that's directly connected to it. How many other carbons is that directly connected to? where we have one carbon here, a second, and a third. So that then is going to be a tertiary alcohol, right? So when you're given these condensed structural formulas, it may be a little bit more obvious than if you're given a line angle formula. All right, so if, for instance, you're given something like this as an alcohol, right? And if you had to name that, first of all, this would be cyclohexanol. All right, we first of all locate the OH. There it is. Find the carbon that it's directly connected to, which is this one, right? Remember, there's a carbon right there. And that is now directly connected to one carbon on the bottom and another carbon on the top, right? So that then would be a secondary alcohol, right? So we're looking to see how many other carbons this carbon here is directly attached to, even though, you know, the remaining part of the chain here actually completes a circle or a ring. We're just looking directly at what this is connected to. So one carbon and a second one would make it a secondary alcohol. The presence of the hydroxyl group, right, imparts some physical properties to your alcohols. So remember that this OH group, this hydroxyl group, is polar, right? So it has that OH, and the OH bond is a very polar bond, the H here being slightly positive, the O being slightly negative. So there's a dipole going that way. And it's able to form hydrogen bonds with not only water, but other alcohol molecules as well, right? So what we're going to see is that relatively small alcohols, ones that contain 1 to 3 carbons, are very soluble in water. And then the general trend that we'll see is as the alcohol increases in size, the solubility of these alcohols in water decreases. All right, so what we can say is small alcohols are very water soluble, and as the number of carbons increases, in other words, as the alcohol gets bigger, the solubility in water decreases. Right, and the reason for that is pretty simple. It boils down to that rule we talked about back in chapter 9, which was like dissolving alike. Right, so when you have larger and larger alcohols, the number of carbons and hydrogens increases, which means the alcohol becomes more nonpolar. As it gets bigger, right? And it becomes more nonpolar because you're increasing the number of these nonpolar bonds, the carbon to carbon bonds and the carbon to hydrogen bonds. All right, we can actually see that here with a couple examples. We have these first three relatively small alcohols, methanol, ethanol, and 1-propanol. They're very water soluble. As we come up to 4-carbon alcohol like 1-butanol, it becomes slightly soluble, and then 5 carbons and above, so 1-pentanol and above, then it's insoluble in water because we're increasing now the non-polar nature of the molecule, right? We have lots more carbons and H's. So the non-polar portion becomes larger. Right? The hydrocarbon chain here is a very non-polar chain, which means that the solubility in H2O will decrease. We talked in the previous, the first part of the chapter about some common alcohols. Some of the properties of the alcohols kind of lend themselves to certain types of uses. And this is especially important now with, the whole coronavirus thing going on. And, there was a shortage of hand sanitizers, for instance. And as you probably know, these hand sanitizers contain alcohol in them, specifically either ethanol or propanol as the active ingredient. Right, so in the absence of soap and water, you can actually use, these hand sanitizers, alcohol-based hand sanitizers to neutralize or kill the bacteria and viruses that are on your skin. Right, and typically they're made up of, at minimum, 60% percent by volume of the alcohol, whether it's ethanol or propanol. But it can be much higher than that, up to about 85% by volume of the alcohol. The other class of compounds that we saw that contain the OH in them was called phenols, right? Remember, phenol is simply benzene with an OH group attached to it. And even though it has that hydroxyl in there, right, you may think that it's classified as an alcohol, but it actually behaves more like a weak acid than it actually does an alcohol. So in phenol, right, there are 6 carbons in it that are in that benzene ring, and as a result, it's slightly soluble in water, because it still does contain that polar hydroxyl group that can hydrogen bond with water. And in water, it actually reacts with H2O, and the H here from the phenol actually gets lost or donated to water, right? So the phenol here acts as an acid by donating a proton to water, and the water there obviously is going to act as a base, and we end up making this ion here called a phenoxide ion. So phenols and phenol derivatives are actually, or were once used as antiseptics, right? Typically, if you go to a hospital and, there's a typical hospital smell or scent, a lot of times that's due to the cleaning agent that they used, which historically has been some phenol or phenol derivative. All right, so the trend that we saw there with the solubility of alcohols is a trend that we'll see throughout the entire semester, which is as you increase the number of carbons and H's, the solubility in water of that compound tends to decrease. So if we have something like this, right, which has 1, 2, 3, 4, 5, 6 carbons in it, even though it's an alcohol, we would expect it to be insoluble in water. Right, because it is a large, relatively speaking, large alcohol, whereas something like ethanol, we would expect that to be soluble in H2O because the polar region of it makes up a big part of the molecule, whereas in the case of, let's see here, we had 1, 2, 3, 4, 5, 6, so this was hexanol. The polar region only made up a very, very small percentage of it. So the majority of this molecule is actually non-polar.